All right, let's talk about reducing radicals. And this is just supposed to be sort of a refresher over reducing radicals and then hopefully help you understand why radical reduction or simplifying radicals, why it works, okay? So so what I'd like you to do first is try this first box on your own. Pause the video and go ahead and put them in your calculator and see what you get for the decimal approximation of each of these. So if you paused and did that, this is what you should get. All right, and so what you see is that you get 8.66 for all of them. All right, so in here we're going to round to two decimal places usually. Unless it says otherwise, you get 8.66 for all of them. So what do you notice? Well, they're all the same. And so square root of 25 times 3 is the same as square root of 25 times square root of 3, which is the same as 5 times the square root of 3. And so some of this you can probably see, like square root of 25 is obviously going to be 5. Let's figure out what's going on here. If I take this number in part A, this is actually a typo, this should say A. So if I take the number into the square root in part A, what would the factors be? Well, factors are numbers that multiply to give you a number. So what are the factors of 25 right here? Well, they're 5 and 5. And then 3 doesn't break down any further. So these are our 3 factors. And so if you were to write this out, you'd have square root of 5 times 3. Okay? How many 5s are under the radical? Well, 1. Or sorry, 2, excuse me. 2 5s are under there. All right? How many 5s were outside of the radical once we simplified? Well, there was 1. Okay, we got down to 5, square root of 3. There was 1 5 underneath. And that works because we can write this as the square root of 25 times the square root of 3. And that's a perfect square. That becomes 5. Root 3 doesn't change. Okay, so that's how this breaks down. And so this leads into a technique for simplifying radicals, square roots, or roots in general, actually, where we try and find pairs of numbers, and then we can take those groups of pairs out in front of the radical. Okay, so I'm going to show you 2 methods for doing this. One is, I think, visually easier to think about, but less useful in terms of practicality, I guess. And then the other one is just the opposite. It's less visually helpful to understand, but also more practical. So let's take the square root of 1200, and we want to break that down. All right, so what we'll do is we're going to make a factor tree. So 1200 breaks into, you start off just picking any number that goes into 1200. I've already filled in part of this for you. You might actually try and fill out the rest of it and see how you do. So if I take 1200 and divide it by 20, that'll give me the other factor. So 1200 divided by 20, and I get 60. Okay, so 20 times 60. And then what does 20 break into? Well, if I divide 4 out, then I get down to 5. And then if I take 4 and try and break up 4, the only factors that it breaks into are 4 and 1, but you want prime factors. That's our goal here, is if we can break it into prime factors, which means numbers that don't break down any further. So that would be 2 and 2. Okay. 60 breaks into 2 and 30. And then what does 30 break into if we take a 15 out? Well, 15 goes into 30 twice, so that breaks into a 2. And then 15 breaks into 3 and 5. And there's no need to write that like this breaks into 2 and 1. You just be rewriting the 2. So I can write 1200 in this way. 2 times 2 times 5 times 2 times 3 times 5. And I'm going to group these in a particular order. Well, I guess I don't need to. 2 times 2 times 5 times 2 times 2. So 2 times 2 is 2, 2, 3, and 5. Okay. And now what I'm going to look for is pairs of numbers. So here I have a square root of 2 times 2, so that's the square root of 4. Here I have another, in fact, let's be a little bit careful here. So 2 times 2, that gives me the 4 here. 2 times 2, that gives me another 4. 5 and 5, that gives me 5 times 5 is 25, so square root of 25. And then the number that's left over here is the 3. Okay, all of these are perfect squares, so I end up with 2 times 2 times 5 times the square root of 3. And then just simplify out in front. So this is 2 times 2 is 4 times 5 is 20. So I get 20 square root of 3. So square root of 1200 becomes 20 square root of 3 in its simplified form. All right, so that's one way to do it, is to use a factor tree and then find perfect squares. What I'm about to show you, what I call the radical reducer machine, is not as visually nice, and it's not going to be as clear where these square roots come from, but it is faster and does keep things more organized. Okay, so let me show you how this works. You take whatever number is underneath the root, so 450 in this case, you put it into the machine. The machine is just a little half box. Okay? Then you ask yourself, what is a small prime number that goes into the number that I have? So what is a small prime number that goes into 450? Well, 2. How about that? 3 works as well, but 2, 3, either any of those small prime numbers is fine. So then you say, all right, well, what is 450 divided by 2? Well, it's 225. Okay. So that goes below it. And then you do the same thing again. What's a small prime number that goes into 225? Well, the most obvious one for me is 5. So I'll take 5. So then I'll go 225 divided by 5, and I get 45. What's a small prime number that goes into 45? Well, how about 5 again? 45 divided by 5 is 9. What's a small prime number that goes into 9? Well, 3. 9 divided by 3 is 3. What's a small prime number that goes into 3? Well, 3. 3 divided by 3 is 1. When you hit 1, you're done. Okay? So this is, if we use the factor tree, this is what all of our factors would be. Okay? Now, we could list out, like we did up here, the square root of all of those numbers, but I'm going to show you the shortcut, which is just, if you just circle pairs of numbers, since we're taking square roots, we circle pairs of numbers, those are going to go out in front. Whatever's left over stays underneath the root. So let me show you what that looks like. We'll end up with square root of 2. That goes underneath the root. And then outside we'll have a 5 and a 3. Remember, pairs of numbers, when we take the square root of them, will become just 1. So just to emphasize where all the numbers come from here, anything left over after using the radical reducer machine goes underneath the root. Pairs of numbers come out in front. Okay, then our final answer then will be 15 square root of 2. Okay, so in other words, the square root of 450 is the same as 15 root 2 in its simplified form. All right, you should try the next two and see how you do. Pause the video, try them, and then see how you do. So hopefully you paused. Now I'm going to go through this one a little bit quicker. What's a small prime number that goes into 392? Well, 2. It's the most obvious one to me. So 392 divided by 2. 392 divided by 2, 196. All right, so what's a small prime number that goes into 196? Well, 2. Then I get 98. Small prime number that goes into 98. 2 again. So I get 49. What's a small prime number that goes into 49? 7. It's the only one. I get 7. 49 divided by 7 is 7. What's the small prime number that goes into 7? 7. I get down to 1. Circle your pairs of numbers. So I have one pair of 2s. That will come out in front. I have another pair of 7s. That'll come out in front. So I end up with this. 2 times, in fact, actually, let's write it lower here. I get 2 times 7 times the square root of whatever's left over, which is 2. Okay, so 2, 7, whatever's left over comes underneath. All right, and then simplify for the last step. So this will end up being 14 square root of 2. Okay. All right, last one we're going to do is square root of 32. I'm going to simplify that, again, using the radical reducer machine. Put the 32 in the little into the machine. We'll take 2. 32 divided by 2 is 16. I'll take a 2 out again. 16 divided by 2 is 8. Take a 2 out again. 8 divided by 2 is 4. Take a 2 out again. 4 divided by 2 is 2. Take a 2 out again. And get down to 1. When you hit 1, you're done. Circle your pairs of numbers. Pair of 2s, pair of 2s, with 1, 2 left over. So out in front then, I will have 2 times 2, again, from here and here, and then the square root of whatever's left over, which is just 2 underneath. That'll end up being 4 square root of 2. So that's what the square root of 32 is equal to the square root, 4 square roots of 2. All right? And that is how you simplify radicals, and that's all we will be working on the worksheet today, is simplifying radicals or simplifying square roots.